Demolition of the old Johnson House building commenced in January 2012. To minimise the disturbance to neighbours on this tightly constrained site, the demolition team erected an acoustic dampening screen around the entire building. The building is supported on 380 secant piles. From these, an interlocking water barrier around the perimeter of the site is formed. To facilitate the construction process, plunge columns were cast directly into the 80 bearing piles. This enabled the project team to construct the superstructure and excavate the basement at the same time. Every pile had to be pre-bored and tested beforehand for unexploded ordnance. The major influence of engineering works on site was the London Underground line, which runs directly through the northeast corner of the development. Due to the roof of the London Underground tunnel only being 2 metres below the ground slab level, it was not possible to form a traditional slab. A design had to be found which not only enabled the structure to be formed, but additionally maximised suppression of any noise or vibration from the trains passing below. This was achieved through a multi-layer slab build-up. First, polystyrene was laid. Above this, a 750 thick beam was cast, spanning between the capping beams either side of the tunnel. On top of this, a latticed concrete box structure was installed. This enabled precast panels to be laid, thus removing any loss of formwork and minimising vibration within this area. The challenge of the LUL tunnel requires a cutting-edge approach and new materials to be used on this high-value project. Acoustic dampening material was further added to the concrete to minimise any vibration through the building. With the ground floor complete, the structure soon began to take shape. To progress the building at its optimum rate, the cores were jumped ahead of the building. This process works by pouring the cores independently. This process is commonly referred to as jumping the cores. Here you see the jump form and how it is lifted into position. This process is a very quick and efficient way of moving the cores up. To ensure safe working practices, working platforms are installed at all levels of the core construction. Once the core is complete, the stairs would then be dropped in, allowing safe access through the building. This process additionally enables the lifts and stairworks to commence at an early stage and gives a tangible benefit to the overall construction delivery time. With the trains running in such close proximity to the building, an innovative vibration reduction system had to be developed. The entire ground floor of this project sits on 340 springs which absorb all vibration and are spread across the entire site. Specialist consultants were employed to ensure that the maximum reduction in vibration was possible. Every spring is unique and had to be placed exactly in accordance with detailed drawings. The springs are preloaded to remove any discrepancies on the datums. This facilitates the precision of the construction. The springs have been designed to automatically release once the building achieves about 70% of the final load. The superstructure is constructed using traditional construction methods which maximise resources and knowledge on site. To maximise work interface across the site, a top-down construction method was used. At this stage, excavation works are being carried out at the basement level, -2, facade works are commencing on the ground floor and the superstructure works are progressing on the 3rd floor. And the cores are at the 7th floor. To maximise productivity on site, wall forms were used This improved the pour durations per floor by around 25%. The basement is fully contained by a secant wall, which acts to support the building but also forms a water barrier to the basement. The excavation works commenced in parallel with the superstructure works above. The completion of the ground floor slab was the trigger for the excavation works to commence to the basement. Earth was excavated from the basement and moved to the mole hole, where it was then removed by the grab. From here it is then transported off-site for recycling. On this project, 100% of the excavated material is being recycled. With the areas excavated, the concrete crews could safely access the areas and form the basement slabs. This process enabled a time saving of 6 months against a traditional bottom-up construction approach. A number of the apartments are located within the lower ground floor slab area. This raises a problem of vibration suppression for them, as they're not benefiting from the springs above. To resolve this problem, the consultant team developed a unique system of placing each apartment on a set of springs. This isolated the apartment from the rest of the building. With the springs in place, the individual apartment slabs were formed resting on the springs. The apartment walls and supporting ceiling structure are then installed. On completion, the entire structure is then raised up on the springs, isolating it from any vibration from the LUL track. Once in position, the finishes are then completed to the unit. The site is located on an island within close proximity to Victoria Coach Station and Westminster Police Station. The surrounding roads are utilised by local residents for parking and are subject to sensitive neighbours. To maintain the fast track programme and achieve the business deliverables, a traffic management scheme needed to be developed that not only considered programme challenges but also external constraints of this heavily congested site. To achieve the programme, the site resources will average out at 400 operatives over the next 12 months, peaking at around 500 operatives in December. This equates to a 5-fold increase per square feet when compared to other major schemes currently under development across the division. Due to the number of working areas under construction, site resources will increase above the levels that the current areas can sustain. To overcome this challenge and not impact on the build programme, a fast, efficient, flat-pack cabin system will be used whilst construction of the main welfare facilities is completed. The purpose-built welfare block will be housed within the ground floor slab area of Ebury Street. From completing the structure within this space to the facilities being open will only take 4 weeks. This will be completed and opened for May 2013. Storage areas on this site are at a premium due to the nature of the project's footprint. This represents another significant challenge for the project team. The project team foresaw this challenge at an early stage of the scheme and realised the solution lay in just-in-time deliveries and developing solutions by prefabricating where possible. A just-in-time delivery management system was further implemented to guarantee that no materials would be left for storage on the podium areas. To arrive at this solution, the team calculated the governing factor lay in the vertical movement of materials and the minimum offload areas. An alternative option needed to be developed which enabled materials to be unloaded and distributed on all floors whilst not impacting the tower cranes. This was achieved through counter cranes. These mitigated the reliance on the tower cranes as they could increase hook time on the site. They could be located directly above the loading bays, allowing materials to be directly transported from the flatbeds to their floor of installation. They further gave a degree of flexibility to be moved up the structure as it progressed, thus negating any impact on the facade construction. A typical flatbed can be unloaded within 3 hours. A canty crane has the ability to lift a safe working load of 2 tons at a jib distance of 8 metres. This represents a modern solution to a traditional problem. These cranes will be utilised for the unloading of a range of materials from facade through to fit out. Due to the nature of the hoist and to facilitate the efficient movement of materials across the floor plate, temporary apertures have been left in the party walls, enabling materials to be transported easily from the hoist to all areas of the slab. Due to the restricted room on the podium slab, it was not possible to set up a traditional sand mixing area for the floor screed. To overcome this problem, an all-in-one screed pump will be utilised for the screeding of the floors across the project. This mitigates the need to have a large storage area for sand mixing and leaves no mess behind. A floor on average will be screeded in 1 week, 1 day. This system further enables additional deliveries to be scheduled into this tightly constrained site. The hoist will be progressively installed with the scaffolding as the structure gains height. This will allow internal fit-out and facade materials to be fed into the hoist, reducing the reliance further on hook time. The hoist will be installed parallel to the building to prevent ramps and loading areas protruding into the podium. The project is now well underway with a target completion date of April 2014.